Our first speaker today, one of my favorite Dutch doctors, Dr. Stephan Kemp. He'll be talking about variants of uncertain significance, friend or foe. So, Stephan.
Well, good morning, everybody. It's really great to see you all in 3D again. To have interactions and yeah, some fun too, because science will also be fun. And I'm a big fan of that. Oh. Yeah, I grew in the last 2 years. Okay, so I'm going to present a topic that, well, I have no idea when it started. Maybe it started in 1999, maybe it started when newborn screening started, maybe it started last year, I honestly don't know. Hey, what happens here? Okay, is this working too? Yeah, nice. So the topic is variants of uncertain significance. So we talk a little bit about biochemistry, and we're going to talk a little bit about genetics. It happened to be my specialty, one of my favorite topics. Okay, just one slide on ALD, because you've heard so much about it. And what is important, I need to decide if I look that way or that way. Patients with ALD, they're born and they have a variant or a genetic deficiency in the ABCD1 gene that results in elevated variant chain fatty acids. And that is a fact. What's not a fact is that we know that we can predict the outcome of an individual. So we have the three core symptoms: the adrenal insufficiency, the cerebral ALD, and the spinal cord deficiency. As I said, we cannot predict that, but we have some facts, and they're listed here. And I'll use this slide again in 20 minutes from now. So we do know that all ALD males have elevated levels of variant chain fatty acids. We also do know that the total plasma variant chain fatty acids do not correlate with the phenotype. And then for the genetics, we know that all ALD patients have a pathogenic variant in the ABCD1 gene. And these pathogenic variants, they have no predictive value towards the clinical outcome. That were those orange question marks on the previous slide. So if you know the variant, there can be different clinical outcomes. So even in families, there are males with cerebral ALD, and then there can be brothers that develop spinal cord disease when they're over 40s. So I said we're going to talk about genetics. I think it's always good to start with the basics. So when we talk about what we used to call mutations, nowadays they're called genetic variants. You have different ones. So you have missense, nonsense, frame shifts, deletions, and variants. And here this cartoon illustrates what they look like. So the blue bar is the ALD protein, and it's built up of 745 building blocks. And in case there's a missense mutation, one of these 745 building blocks is changed. So that's that little square over there. So you have the whole protein, and there's just one building block is changed, and that's a missense variant. And then you have a nonsense variant, and that means that normally it stops here, but now it stops here at the blue point. So the genetic variant results in a stop, and then so you have a short protein. And then you also have a frame shift, and then the blue part is the LD protein, and then something, because of the mutation, something happens, and then you suddenly get another protein, and that's not functional. And you can have a deletion in which a part of the protein is gone. And the clinical consequences of these are that a nonsense, a frame shift, and a deletion, they're really deleterious to the protein and its function, and these are all disease-causing. The problem is a missense variant, because is this change, is that disease-causing or is it benign? And I'll come back to that also later. That's why I said maybe it started in 1999, because in 1999, when I was at Kennedy Krieger, together with Hugo Moser, we started the ALD database, which is now called the ABCD1 variant database. And it was just like a fun project, listing all the mutations that were found there, because it was clear that there were a lot of different ones. And I thought it would be nice to share that online. And in 1999, it was well, last millennium. You could build your own website with an internet HTML for dummies. So I did that, but I cannot build this. So these are friends of mine who helped me with this. And so it evolved from just a collection of mutations into a website that has talks about a lot of different topics, and also in several different languages. And this is all done voluntarily by students that visit Amsterdam, or collaborators from the United States or from Germany, that voluntarily translate these information pages into other languages. But on the website, as I said, it's also the ABCD1 variant database. And it's becoming a huge selection of variants, because currently there are over 1,000 different unique variants identified in the ABCD1 gene. And they're all reported in the database. And these are the different variants that I mentioned, and there are even more flavors. But and here are the missense variants. And they make the largest group. So over 500 different missense variants have been reported. And you can also see that here it is listed pathogenic, likely pathogenic, the variant of uncertain significance, likely benign or benign. And benign means that, yes, there are these building blocks that you can change, and the protein just functions normally. And these used to be polymorphisms, and these are benign variants, and they do not cause disease. But you can see that here it's all, the majority is pathogenic or likely pathogenic, but here in this area of missense variants, you have them all over the place. And so now if you do newborn screening or random genome screening for whatever reason, because you suspect the person to have a disease and you have no clue, but you can do genome-wide screening. And if in the case you end up with identifying a new missense variant in the ABCD1 protein, without any clinical clues and clear-cut biochemistry, there is a diagnostic uncertainty. So you need proof whether this is causing disease or if it's not disease. And of course it has big consequences for the individual. And I would like to give you two examples. And the first is about the women. So I think it was 2014, there were two unrelated Dutch women, and they had clinical presentations that resembled ALD, but it might also be multiple sclerosis. But anyway, it was not clear if they had ALD. And of course, then you just measure the plasma variant fatty acids. And you can see here in controls, the green ones, and then in blue are the males. And in all, as I said, all males have elevated variant fatty acids, but that's not the case for women. So, so there are women that have ALD, but their plasma variant fatty acids are normal. And that we know from the 80s already, and it's very consistent. About 15% of women with ALD have normal plasma variant fatty acids. So, when these tests were done in these women, the results are shown here. So both of these women had a new variant, so a missense variant in the ABCD1 gene. They didn't have any affected relatives, but one of the women wanted to start a family and wanted to have a child. But she said, well, if I have an inheritable disease, I don't want to get pregnant. If I have MS or another acquired disease, I may decide that I want to have a child. So it was really, we said, well, we have to solve this. So the question was, are these variants, are these pathogenic? And this is not an easy task, because women have 2 X chromosomes. And in each cell, one of these X chromosomes is active. So the variant is on one of the 2 X chromosomes. So you have cells that are normal, ALD-wise, and you have cells that are ALD and have the elevated variant fatty acids. And the body is a mixture of these cells, and this is a random process. And normally it's 50-50, but often it's not 50-50. And it can be close to 100-0 or 0-100, and everything in between. So if you want to do biochemistry, this is probably also one of the reasons that women can have normal variant fatty acids. So we thought of a test a diagnostic test that we could do. So we took skin cells, and these skin cells, as I said, you have cells that are green, so they have the one X chromosome active, and you have the pink ones that have the other X chromosomes active. But it's hard to do biochemistry on this. So what we did, we immortalized these cells, and we made clones. And the clone is that you start one cell, and it starts dividing, and all these cells are equal. So we plated them, and you have this cell then has normal ABCD1 protein, and this one has the deficient ABCD1 protein. And then what we did then, we expanded these, and then we picked 3 of each, and then we just did our basic biochemistry, because now we had cells that only had 1 of these X chromosomes active. And these are the results. So we did this for the 2 cells for the 2 women, but of course we took controls. So we also took 4 cell lines from women for which we knew that they have a pathogenic variant. And here you see the results. So if we isolate the clones that had the normal ABCD1 protein active, you see that the activity was normal, and the pathogenic allele was as we measure in males, was deficient. And when we got the results from these women, you see that whatever X chromosome you investigated, the results were normal. So the conclusion of this was that these are benign variants. So these women did not have ALD. So this is very cool, and we were proud of this, but it took us a year to do this. So this is not a diagnostic assay. And then we said, well, we have to improve this, because these 15% of false negatives is a major problem. So the sensitivity of the plasma variant chain fatty acid assay is not sensitive enough. It's also not my favorite assay to do, because it's very time consuming. So and it's costly. So our diagnostic laboratory in Amsterdam also said, well, we want to get rid of this assay. So why don't we compare the C26 lyso-PC, which is the newborn screening biomarker? So we screen babies with C26 lyso-PC, and then when there is a result, we do plasma variant chain fatty acids. And then they said, well, it doesn't make any sense. We should standardize it. So we decided to do I think for 2 years, whenever there was a question for variant chain fatty acids, we did both tests in parallel, so we could compare the results. So we had blood, and then we isolated plasma, but we also made blood spots, because this is what we receive for babies. So we could analyze all this. And so this is the graph that I showed you before. That 15% of the women have normal variant chain fatty acids, and when we do C26 lyso-PC, you see that they're all elevated. So the conclusion is that the C26 lyso-PC is a superior biomarker. It's also much easier, and now we can screen everybody suspected of ALD with the same biomarker. And the nice thing is also, and I think when we talk about community, the option of sending a blood sample across the world is expensive. You need at least a FedEx, and then you hope they don't get lost the package, which every once in a while happens, but it's costly. But with this C26 lyso-PC, you can make blood spots anywhere on the world, and then you take a few blood spots, you put them in an envelope. Yeah. Oh, fly. What? Yeah. Put the envelope in the mail. Yeah. Thank you, Patty. Put the envelope in the mailbox, and then fly across the world to either to KKI or to Amsterdam, and have it analyzed there, and then you send the results, and that's of course much cheaper. We have one stamp. So this was one example. Now the other example is newborn screening. So and I think I need to make some understand. Well, I have no idea what I'm going to say, but until newborn screening, a patient would visit the doctor, and there was a clinical exam, and when the doctor thought, well, this could be ALD, you take a blood sample and you send it to the lab. You do biochemistry, you do genetics, and 1 and 1 is 2. If you have elevated variant chain fatty acids and you have a variant in the ABCD1 gene, it's ALD. Case closed. But now we have newborn screening. So there's this baby born anywhere on the planet, gets a heel prick. The blood spot card is sent to the newborn screening facility, and then it's elevated. But but yeah, it's not normal. It's elevated. But you see that where is ALD? And I'll come back to that later. And then if you do genetics and you find this variant of uncertain significance, so a missense variant, then this baby doesn't have any clinical signs or symptoms, so there's no clinical clues. So you're missing one part of the equation. So then there's a diagnostic dilemma because of lack of information. And trying to visualize this in another way is that, so before newborn screening, this is the patient visits the doctor, biochemistry, and you see that the biochemistry is there's a range here, so there's the blue range, and then if you screen the whole population and you have all your controls, you have the established control range, but these two regions, they don't connect. There is a gray zone in between. And it's a game of numbers. So if you screen millions or hundreds of thousands of people, you will find individuals that do not fit in this group, but they are a little elevated. If they're over here, then it's very likely ABCD1, and if you also then have a pathogenic variant. But if you now find an individual in the gray zone, and you find a missense variant, so one building block changed, you again have a diagnostic dilemma. Yeah, okay. So in population screening, there's a trade-off in fear of missing somebody, but that's why. So as a result, the cutoff levels are lower, and therefore the number of screens that you send out for the genetic testing is higher, and therefore the chance of finding something that's benign and new is also higher. But the question, of course, is this a disease-causing variant? And is there a benefit for the newborn? Does this newborn benefit from being coming out of a screen? So the summary, well, I think I said enough about this. So the hypothesis is that there should be ABCD1 variants out there that may affect the biochemistry marginally. And then the question is, do these cause in late onset variants? Because ALD is also a spectrum. Any disease is a spectrum, so ALD is also a spectrum. Or are these harmless? Are these benign? So, and they do not cause disease at all. Okay. So back to the genetics. So this is the slide I showed you before. With over 100 variants of uncertain significance having being identified over the years. But something interesting or scary is here, because almost all of them, they come from newborn screening. And I would like to present two cases. So this is a variant, arginine 418 is changed to a glutamine. So one building block is changed. That was identified in New York State newborn screening. It was also present in a database on the internet. And because there are no clinical clues, it's a variant of uncertain significance. We received fibroblasts in Amsterdam, and we did our biochemistry, and we did see that the variant affects the protein function. So then we could say, well, it's a variant of uncertain significance, but it's, oh, this is the next slide, sorry. So now it's classified as a likely pathogenic because it does affect the biochemistry, but you still don't have any clinical outcome. So you never can say this is pathogenic. So in 2020, it was reported once. In 2021, it was reported in New York State, in California, Pennsylvania, Texas, in the Netherlands. And then we did the test with the fibroblasts. So then we moved it from a variant of uncertain significance to likely pathogenic. And this likely pathogenic is purely based on the fact that we have biochemistry. But none of these families had a history of ALD. And yeah, there was one unexplained neuropathy in a male, an old male that had passed away, but neuropathy at over the age of 60. Yeah, was it undiagnosed, unrecognized ALD or something else? And we cannot answer that question because the individual is not there anymore. But since I'm holding this registry since 1999, the simple question is, why was this variant never seen before in a clinically affected individual? So between 1993 and 2020. And since 2019 or 2020, 8 times. That doesn't add up. I just showed you that there are 1,000 different variants, and some of them are unique. And now suddenly we have this one variant that we have never seen before, and now we see it every time, and we see it in newborn screening. The second case is a lysine 523 to glutamine. This was identified in California, Minnesota, and in Texas in newborn screening. And it was also an incidental finding in genome-wide screening of an individual with signs and symptoms, no clue what this disease is. Then we do OS, whole exome sequencing, and this variant was identified in an individual in Israel, and also in the US, and also in Germany. So again, we did function study in fibroblasts, and yeah, there was the biochemistry was different. It was not normal, so we classified it as a likely pathogenic. But here again, none of these families reported a history of ALD. And well, the extended family screening identified adult males with this variant who were clinically completely normal. Males over the 60s, and they never heard of ALD, and now they have a sticker on their head. I have this variant, and now I certainly do have ALD. And of course, then the variant safety are measured, and yeah, they are elevated. But elevated doesn't mean a lot, because are they elevated in the ALD range, or are they in the gray zone? And if you just say they are elevated, that's not very, it's not very clear. And again, why was this variant never seen before newborn screening? And now it says 10 here, but I took to some of my colleagues, and it's 14 by now. So that's smelly. There should be something going on here. So I said, and so this problem started to be, yeah, I think 2017 was the first one of an AOD Connect meeting. It was the first time we talked about this, and it's been building up. And then you think, well, these variants of uncertain significance, is this unique to ALD? No, it's not. There are newborn screening programs in Italy for Fabry. And since the start of the screening for Fabry, now they find late onset forms that they do not want to find, because these individuals do not benefit from newborn screening. Also in breast cancer, about 25%, 20 to 25% of the variants that are found there are unclear whether they are disease causing. In cardiovascular disease, the same story. It's also about 20%. Every time is about between 15 and 25% of the genetic findings are unclear. Oh, this is all. Let's see, I repeat myself every once in a while. So we see variants of significance. The question is, are these pathogenic, late onset, or benign? And these newborns, yeah, they have a C26 lipid level that's above the control level, but it's below the established ALD range, so it's in the gray zone. So these are screen positives. And so these individuals, they will be referred to a metabolic center or to a specialist. And the question is, are they at risk for developing adrenal insufficiency or cerebral ALD? So do they benefit from newborn screening? Or are we creating patients? And that's not a good thing. So we need to tackle this. We need to work on this. And the downside is, if you find too many false positives in newborn screening programs, and you send too much families into a healthcare system unnecessarily, that may jeopardize ALD newborn screening. So there is a real reason that we should work on this. Not, first of all, of course, for the families who are faced with this, but also for protecting the newborn screening program, because the balance of benefits and risk is out of balance. So action is required. So in I think in March, at one of the AOD Connect board meetings, we talked about this. And then Josh Bankowski, Troy Lund, and we sat together, and we developed a pilot study, a plan how to do this. And it's now been funded by AOD Connect, this pilot study. And we call it the Gray Zone, with its own logo. And I will tell you what we're going to do. So, of course, we start with the database. So I already had an inventory of all these variants. So these are the two that I just showed you, but there are more. There are over 100. Of course, these families do not have an ALD history, because otherwise it would not be of us. It would be likely pathogen or pathogenic. And then we make a top 10, and we will start with those. And this is a slide that I showed you at the beginning. We have two facts. All ALD males have elevated variant safety acids, or C20-lyso-PC, in the disease range. And all ALD patients have a pathogenic variant. And we can use this knowledge for getting insight in these variants of uncertain significance. So what we do in this project, to extend the family screening and also from other sources, we will find adult males with the same variant. Then it's required that these adult males see an ALD specialist, because we really want to know, are there really no clinical signs and symptoms of ALD? Then preferably we would like to have a fibrillous sample from one or two or maybe three identical variants for biochemistry. And we want plasma samples. And I say if you do one, well, people say, yeah, I don't really believe it. So preferably at least 3 to 5. And then in the plasma we will measure C20-lyso-PC, but we will also do the lipidomics that Jorik talked about yesterday, because we have more biomarkers and we're working on this. So this is one of the examples where two projects come together. That knowledge we can use for this project. And a requirement for me is that this all be analyzed in one laboratory with established control and disease range. So we know exactly where the disease range is. And yeah, that happened to be in Amsterdam. And I think this is my last slide. So I think it's really, I hope it's really clear that this is a really worldwide, because this problem is not just America and the Netherlands, it's also in other countries. So this is truly a worldwide ALD community project, because we need the families, we need the physicians, we need the grandfather helping his grandson. Because if the grandfather doesn't have ALD, his grandson doesn't also have ALD. That adds up, and that we and we do this all together. So I think this is a perfect project for all of us to invest in, and because we need to solve this problem. With that, yeah, I have no idea what the time is, but thank you.
Thank you, Stephan.
I also have one more slide.
Oh.
My colleague Mark
Suspense.
Engelen, he's not really into social media and everything. He did a trick yesterday with the QR code. Last week I was interviewed by the Journal of Inherited Metabolic Diseases for a podcast. The podcast is about ALD newborn screening and the fact that we do sex-specific screening in the Netherlands. But the whole conversation also went into the VAS thing. So if you want to listen to it, it came online yesterday. Perfect timing.
I don't see many phones.
No, it's in
out.
English.
Where are all those phones? Get them out.
Yeah.
Download the podcast.
And I promised James Nurse, who is the social editor for the Journal of Inherited, that I will do my best to get high on the list of listeners, because they notice that some of the podcasts that are about ALD are really highly ranked, and we can use that because then this journal becomes even more interested in ALD. Think about that.
Awesome.
I leave it up there. Yeah.
Thank you, Stephan. All right, we've got a few minutes for questions. I see a few over here on the left, so I'll just start with who I saw first. This one's on.
Is this working? It's
Yeah.
working. Hey, hi.
Hi.
Hi, Stephan. Thanks. So as a genetic counselor, this hits very close to home because I'm the one who's faced with counseling these patients and families and making decisions with this uncertain information. So thank you. Another scenario that I run into is patients who we know have ALD and we order clinical testing and the lab identifies a variant, but they classify it as a VUS based on ACMG criteria.
Yeah.
And it's appropriately classified that way. And I have to go a lot of the extra miles to convince them to reclassify it. So I do worry about when these patients are seen by non-expert centers and they kind of leave it at the VUS. So that's just a comment, but I'm wondering if you can comment on the ClinGen efforts for a variant curation expert panel. I know there's one for paroxysomal diseases. I'm not sure if you're still involved with it and what they're doing and how we as a community can also contribute to that.
Yeah, they are, and I try to follow the guidelines. Uh, but yeah, if and there's, well, if you find 1 times this variant or 2 times this variant, then according to the guidelines, it's still likely. But if you have a clearly clinically affected male, and you have 2 ones, and they're not from the same family, and they have clear biochemistry, do we still say this is likely pathogenic? So I follow the rules, but that's why on the database, the variant database, I'm now counting cases. Didn't use that before newborn screening, but when I met illegal Seeger, it became clear to me that now there's a whole new population that needs to benefit from the database. So I rebuilt it completely and started collecting all the cases since the early reports from 1992. Crazy job, but it's worth it. And I hope that that level of extra information, and I curate it. So if there's scientific information from research papers that provide any additional evidence that this is maybe this is limited information from the patient, but if you use the fibrillous cell line in a research study and there's no protein, you can add that information together. And that's something that you don't see in ClinVar or any other database, and I think the ALD database is unique in that. I don't think there are many other examples.
Hi, that was terrific. I think one of the things that is important about VUS resolution is IVF and preimplantation genetic testing, is that many reproductive labs won't use a variant of uncertain significance to determine whether or not they can use an embryo. And for women who, for very long chain fatty acids, have a 15% chance of scoring in the normal range, this is really a dilemma.
Yeah.
And so many of the women ask me, should I get biochemically retested, the 15%? So that was my question, is there, what's the, within an individual variability of the lyso-PC testing versus the very long chain fatty acid testing?
Thank you for asking this question. This is an excellent question because I can again say that lyso-PC is superior because plasma variant chain fatty acids are notoriously, there's an effective diet. So a ketogenic diet effect, you have false positives with the ketogenic diet. If you don't have a fasted plasma sample, you can have elevated variant chain fatty acids. But as far as we know by now, that does not happen with C26 lyso-PC, because the C26 lyso-PC it's in the membrane. So if you eat something, it doesn't immediately enter into the membrane. So we look much more specific. Well, of course we will keep investing in that, but as far as we know now, and your question, they're stable. So if you measure, so that's all the data that we have so far is that okay, there may be 10-20% change, but they are through life they don't change. Sorry,
Is the variability as tight in that gray zone as it is in the...
In the gray zone, we don't know. We only work in the blue zone and in the green zone.
Okay, so one question
Ben,
here.
where are you?
Ben.
Yep.
So yeah, I think interestingly, after I made contact with families who had gone through newborn screening, and then 15 relatives get tested. And I heard story after story of men in their 60s who had the ABCD1 mutation but had no symptoms. I heard a story of 3 uncles who were farmers in the heartland and were like in their late 60s and had no deficits. So that explains that. So the other question, to make it real, is we could have boys who have the mutation, are slated for the standard of care to undergo MRIs every 6 months for no reason, and they're unlikely to ever manifest the disease. But they're, of course, undergoing a huge toll, emotional, financial, operational toll on the family and the system.
Yeah, exactly. Yeah, thanks. That's exactly what we should do this for all those reasons. Amber?
Yeah, Stefan, this was great. Thank you. So I had a question on the assay that you don't like doing, that big long fibroblast. If you did that on women with ALD, what would they show? Do you know?
You mean the first, the fibroblasts, the clones that I showed?
Yeah. Did you do? You know how you said that biochemically these VUS variant, that you did see a biochemical issue?
That's this
No,
one.
no, no. But
Sorry.
maybe I misunderstood. So did you also, when you were trying to confirm it for women, that was one thing. But if you compared that, sorry, I misunderstood. So when you took a male who has this unknown missense variant, was it a similar level? Do you know what I'm trying to say?
Yeah. That's so I think that's one of the problems is that we did these fibroblast studies for some of these individuals, and the results were that it affects the protein, and we concluded, well, this is maybe a deleterious protein or a missense variant. But I'm starting to doubt our own work in here because I think the assay is too good. So because in any enzyme assay that you do, you see variants that affect the protein enzyme activity to 70% or 80% or 60%, and you can really measure it very good. But in a transporter, that's much more difficult. So we do this assay for the freaks with 30 micromolar, and I think that's too high. It's too choose different colors, too green and blue. So we are so that's part of this project is that's the research part. That's not the diagnosis part. That we also use these fibroblasts and we do KM studies, temperature sensitivity, lower concentration. We're already working on that for one of the variants, and because I think we need to go much lower to really get more into. But I think that answers your question.
All right, we got a few more questions here.
Hi, thank you so much for this presentation and your work in general. I say all the time, I think I share your website more with families than I do ALD Alliance or ALD Connect, so thank you for everything that you've done. My question is about the pilot, which I'm also super excited for. I'm curious about how you're going to quantify the symptoms, because I know even with pathogenic variants, there's like this really wide range. So when they meet with the ALD neurologist or whatever, what exactly are you guys measuring, and do you care about the anecdotal stuff, like maybe the restless legs that, at night that never really amounted to anything more, like things like that?
Yeah,
like how is that going to be?
Yeah, absolutely. So that's why this is community broad, because all the ALD experts who do see the patients, that's why I say these grandfathers and adults, they need to be seen by an ALD expert physician, because if there is a very mild phenotype, that's also good, because if it turns out that 10 of these old males have very mild phenotype, then this is a variant that's on the completely different side of the spectrum. And then you can question, do you need to pick up these variants in newborn screening? Because these little kids, they don't benefit from knowing that when they're 60, they start developing mild symptoms. And I'm sorry that I say mild. And the first role in newborn screening, that it should be beneficial to the newborn. And then you can, no, I'm not going to the male girl because I'm undetermined in that. I think both if you test boys and girls or only boys, I have no opinion on that because I still am in the middle. But there's no benefit if you know that when we also don't screen for other late onset disease. We don't screen for Parkinson or whatever late onset disease. That doesn't qualify newborn screening. So yeah, that's why the experts need to see, well, this is mild, or this is no ALD, or this is mild.
Stephan, over here in the middle. Great talk, and I'm going to piggyback off, I think, the last two questions with the idea of not just finding what is causing, but maybe helping filter away things that are not causing. Are there any other databases available? I know you mentioned Nomad and Clinvar, for instance, that have centenarians, supercentenarians, individuals that are healthy over a certain age that you could use to filter out some of these VUSs as potentially not beneficial information for NBS.
Yeah, that's an excellent idea. But these variants, these VUSs, they're super unique. They're in the Nomad database. That's, I think, 200,000 genomes. They're not there. Well, sometimes they're there, but then they're pathogenic, and I wonder, how did these end in there? Yeah, but a few are in there, and that gives us some clue where we should be looking.
Dr. Kemp. Oh. Hi, Dr. Kemp. Thank you so much for doing this. So for the pilot study, is there going to be like a reliable way to know whether the boy's in the gray zone, it's a benign, variant? Just to piggyback on what Ben said, I think more importantly, these kids picked up on newborn screen, like family planning for them is, I mean, not alone are they going through MRIs every 6 months and all of this, but more importantly, is this important not to pass on? Is this a variant that we want to, not pass on, or because family planning is going to be like a big deal for these boys and for the girls?
Yeah, it is true, but there are different outcomes here. If these are really benign variants, they've been passed on for centuries and never being recognized as ALD pathogenic, because these individuals never ended up in a clinic with symptoms. And of course, it can be that they were missed. But if you look at the database since 1992 to 2018, they've never been there. And now suddenly you see them 10 times. They should have been there at least once. And that's why it doesn't add up. And it is it's always nice to look in the future, but if the outcomes are that we can prove and that everybody believes us, and we all agree that this particular variant is really either no ALD or extremely late onset, that should be registered somewhere. Because another thing in the United States is that so when newborn screening is done by the ctDNA ELISA PC and the DNA diagnostics is done, this is often done by commercial companies. And I get WhatsApp messages from families, emails from families with screenshots saying a VUS, and then the family said, "How can this be a VUS? Because you have 10 affected ALD males in your database." Yeah, and then I say, well, these companies probably don't look at the database because it's free. I don't know why they don't use it, but it's bizarre. You see things, results, and some of the states, they are not allowed to edit that information. By law, they're required to pass on the information. So even if the experts see the information and say, "Oh, this is," but they cannot do anything about it. So this is a complicated thing.
Dr. Kemp, we have a Zoom question. Are you taking enrollees, or how are you going to determine who's going to be part of this?
Oh yeah, that is of course an excellent question. Well, I think it's also done by the requirements. So we need adult males that have the variant and that have no clinical signs or symptoms, because it's a fuss. And they need to be seen by specialists. So for some of these variants, many of my clinical colleagues, they already are seeing them and are storing plasma samples for as soon as we start. So yeah, I can say we work on the list, but if the number 3 variant on the list, there are no adult males, then we don't do that. So we wait. So I think we just start. I mean, we are really eager to start, and we're just waiting for the information from our colleagues and material.
Stephan.
Hello.
So do you think there's ever going to be a risk? So we know that any mutation can affect any male very differently in a family.
Yeah.
So for example, my identical twins, cerebral ALD, but there's no one else in my family who, my father had Addison's disease. Do you think that there was, ever going to be a risk that these VUSs are at some point going to change and be disease-causing?
Yeah, that's a great question. So it's true that monozygotic twins can have different clinical phenotypes, but if you look at the biochemistry, they're both not in the gray zone. They're both in the disease thing. So it is ALD, but we cannot predict which clinical form of ALD. So the second question is, yeah, it is possible that we make a mistake. But what my newborn screening colleagues always tell me, newborn screening, population screening is not 100% sure. You try to reach 100%. If you reach 99%, there's a benefit. There's a trade-off of investment, time, and everything, and catching the individuals that benefit from newborn screening. And it can never be 100%. But you try to be as close to 100%. But
so I suppose the variants of unknown significance will still be registered anyway, won't they?
Oh,
so
yeah, absolutely.
If further down the line, something crops up, you'll be able to sort of see it. I've also been handed another question, which is, what are your thoughts about head injury and the onset of cerebral
I'm not a
ALD?
clinician, so
save that one for someone else.
We can say
I should. No, they're Florian, Troy. I mean, I'm not going to answer that question. I know there's literature, but I only know literature. So Florian, Troy.
Karen, we can save that question for the Ask the Experts panel this afternoon.
Any other questions? No. Okay, let's give it. Oh, we have one more. One more
One
question.
last question.
Would this potentially affect people who are marked as likely pathogenic on the variant database?
Sorry.
Some people are marked as likely pathogenic.
Yeah, because many of these variants, we did the fibrous test that I just told. They're now likely pathogenic, but I are starting to doubt our own assays because the assay is too good. Well, it's an oxymoron. It's not too good. It's too green and blue. So we need to do it again for these variants because these variants are tricky. But let me put it another way. So in many diseases, if your residual enzyme activity is 30%, which sounds like horrible, you don't get sick. So why would that be? Why would it not be the same for ALD?
But for people with a deletion, it's just no.
A deletion is pathogenic. Then I bet you the variant safety acids or the lyso PC are in the ALD range. You only see gray zone variants with one building block being changed.
Interesting. Okay, thank you so much for doing all this.
Whenever there are questions, I am around. So because I think we were really running out of time.
We are, but this was a great
Sorry.
talk, so we wanted to provide plenty of time for questions. So thank you so much, Dr. Kemp.